Assalamu alaikum, my friends. How are you, everybody? Today, I will discuss about the design of a PILECAP in ASHDIP Foundation software. Uh, okay, let's start. First of all, I will open my software ASHDIP Foundation from the entry phase shortcut. Okay, I have already opened it and click on PILECAP. Okay, let's give a name PILECAP. PILECAP. Okay, add and select PILECAP from this box and open. Okay, before starting and give starting assign any input, we must follow some step. Mm, in the design process, I will follow these steps. First of all, unit setting, then geometry, then load assignment, material assignment, load combination, reinforcement setting, and then checking result checking, and finally printing the output of the result. Okay, let's start and see step by step. Okay, first of all, I will set the unit. Here in unit shortcut, I can set my unit or design design in design we can set and the unit. Here the unit is US unit, SI unit, and MKS unit. I can set any of this, but I am keeping the US unit. I am comfortable with US unit, keep it in or KSI. Okay, then second step is geometry of pile cap and column setting. Okay, first of all, geometry. Before setting my geometry, I need to know the number of number of pile required for this pile cap. That's why I need the mm, column reaction to calculate the number of pile and pile allowable capacity um, from the soil test report. Then let's see this. I am designing the pile cap of this building, and here let's see the support reaction of column. Here I am following the BNBC code, and that's why I will I am showing the BNBC load combination here. Okay, then I am taking the service load condition here. Total service load for pile. Let's see that I will select this column for pile cap design, and here the total service load is 894 kip. Okay, I am taking the 894 kip. Let's see, I'm writing this load equal service load equal 895 kip. Okay, and now I will check the pile allowable capacity or ultimate capacity. Here this is my salt report, where from where I can calculate the bearing capacity. This here the geotechnical engineer already calculated the ultimate or allowable bearing capacity and proposed. I will check the where I want to release my pile. Here I see that the pile I need to release the pile in this portion, either in this portion or in this portion. I cannot release my pile here or here, because after this there is a loose condition, there are loose or soft condition. That's why it will be risky for pile design or foundation design. Then I will release this pile in this portion, here or here. Okay, let's see, 25.5 meter or more, maybe 27 meter also. Yeah. Then let's see the pile capacity. Pile capacity is, the technical engineer already calculated the pile bearing capacity for this project. Okay, here here the pile capacity is, I have already shown that I want to keep the pile capacity as 25.5 or 27, so 27 meter. Here the pile capacity, ultimate capacity is 27 meter. Ultimate capacity is 298 for borehole number 2. Here the pile diameter is 20 inch and borehole number 2, and for borehole number 1, for 27 meter pile, the ultimate capacity is 301. Then we will keep the 298 is the conservative, so I will take this on 298 ton for my pile bearing capacity. Okay, here uh, 193. Okay, maybe this value may be also may be used on 293 here. Here the pile capacity did not rises too much. That's why we can also take this one. Let's see, let's take this value 25.5 meter pile with pile capacity 658 kip. Okay, pile capacity is 685 kip. Ultimate pile capacity 658 kip. 58. Okay, hello people, pipe capacity equal to 658 भाग 3 equal 200 ton, sorry, 200 cube. Okay, before using the final service file, we must check this capacity by pile load test to confirm the bearing capacity, theoretical bearing capacity has been attained. Okay, now total number of pile, total number of pile required equal to load by 95 divided by 200 equal to 4.1 equal to 5 knots. Okay, now we will use the 5 knots pile to um, support this column. Okay, here another thing is the size of the column is 900 by 400. Okay, let's input here. Here total number of pile I have calculated already is 5. Here it is only used to show the typical dimension, that's why it is not changed. If I want to change the graphical part, then select the graphical part and you will see this. Okay, pile number, pile is from pile edge to distance, that means pile center to edge distance. Here I will use pile size equal to 20 inch and I will use the pile size 20 inch. 20 inch means 1.67 feet. Pile spacing is 3 into pile diameter, that means 5 feet. Okay, accidental pile offset 3 inch, sometimes it may not required, but I am showing here. Pile top embedment, pile top embedment is 4 inch. I will show 4 inch pile top embedment into the pile cap. Okay, this is pile cap. If I want to use the better pile, then I can select here to make it angular. Okay, I am selecting one to show it. In our Podda bridge, already pile has better pile has been used. I have shown 4, 3. Okay, both of them are better. That's why it is showing angular. Okay, I will not use here better pile. That's why I'll tick off the better angular part. Then this is geometry for pile. Then I will select pile cap. Pile cap length already calculated from the pile details, and pile cap thickness. I will trial it. Pile cap thickness. Let's first of all let's assume the pile cap thickness is 36 inch. Soil cover is here. The soil cover SC. That means here the soil cover is 5 feet. Water table can be from the soil test report. You can use water table. Here the water table is What is the water table? Groundwater table 2.26 meter, that means 7 feet. Okay, water table is 7 feet. Okay, now the pile column geometry. Here the column has been shown as offset, but I will not show any offset. Column length here the column length has been shown as 900 and 400. With column width is 400. 900 means 36 and 400 means 16 inch. But since the pile cap is this column is contract with soil, so I will increase the pile column size here and here. Okay, there is no offset in column from the center, but here it is showing because it is showing the typical dimension. That's why it is showing by column offset. Column is a short pedestal, that means the pedestal dimension is 5 feet. Okay, lateral load applied at the top of the pedestal. Okay. Then I will show the load assignment of load found from column reaction. Okay, here the total okay, I will make a TDL, total dead load, TDL, total dead load 1 1 1. Then where is TDL? Okay, here is total dead load is 729 kip. Okay, total dead load is 729 kip, and here dead load moment is dead load moment is here the dead load moment is 1.x equal to 1.5 2.7. Okay, 1.5 2.7. There is a sign convention here. The sign is x and z, but in ETFs the sign is, this one is x and this one is horizontal to axis. In ETFs is x and y, but here it is x and z. That's why it is not matching with each other. Okay, shear force Vx and Vz, but in ETFs Vx and Vy. Shear force Fx equal to 1.13 and F y equal to 0.7. 1.13 0.7 is the okay. Then live load reaction is here two types of live load. So I will total live load reaction is in which total live load reaction live load can say which load has been considered. Live load, two types of live load. Okay, total live load reaction is on 52 on 100 152 cube and live load moment equal to 0.1, 0.1 and 0.7, 0.1, 0.7 and 0.3, 0.15, 0.3, 0.15. Okay, and roof live load is here. Roof live load is roof live load. This is roof live load. Roof live load is 13 kip. 13 kip. Moment is very negligible. Very negligible. I can neglect it. Okay. Then wind load. Wind load. Then wind load. Wind load is very negligible. That means 1.3, then 3.9, 1.3 is negative. That means upward. And 3.9, 3.9, 8.3, 8.3, 1.98 and 0.34, 1.98, 0.34. Okay, then seismic load. I will check for seismic load. Okay, EQ. Okay, Q X Q Y envelope maximum. I will take the maximum value. Okay, EQ. For seismic load, the vertical load is minus 1.16 minus 16. Here minus 16, then 200, 84, 200, 84, 16, 20, 20 and 16, 20 and 16. Okay, my load define already completed. Now I will show the material definition. Here the material for pile capacity is here we have used the pile allowable pile capacity is 600, 219. That means we will use 200 ship site, 200 keep, 200 keep to make a ship site. And tension capacity, less the tension capacity is 70. That means 70%, 50%, 70, 70 keep. Yes, lateral capacity is 10. Let's say do it 10 keep. Okay, I have not already calculated, but it need to be calculated by screen friction. 0.75% of is total screen friction plus weight in this way, and lateral capacity must be calculated. I have assumed just the these two value. Okay, then PILECAP. Concrete strength capacity. I will select it here. 4 KSI and river strength 610. Concrete density 150 pound per cubic feet, and soil cover over the 100 10 pound per cubic feet. Okay, and I will select the same capacity of pile cap and column. Okay, here the pile column is 400. Same. Okay, now I have completed the unit setting, geometry, and load assignment and material assignment. Already I have completed these 4 parts. Okay, now I am starting the load combination. Okay, here the load combination. Here there are some default load combination for AC 7 or 10 or oblique 710 oblique 16, and another one is AC 705. Now I want to user defined load combination. That means I will, here my load combination is 1 1 1. I will save it as pile, since it is 5 pile cap. Okay, I will select service load 1 for live load on 1, everything is 1, and another one is factor load combination is 1.2, live load is 1.6, and dead load is 0. Group live load is 0.5, and another one is 1.2, 0.5, 1.6. If we want to enter the lateral load, enter the combination in lateral load in combination, then select this type of combination, then select this type of combination and this type of combination. Okay, I will not say use here the load lateral load combination. That's why I am ignoring this service load, factor load. Okay, now my design criteria. Condition footing is restraint against sliding, include pedestal in passive resistance, include passive in overturning. Okay, I am not selecting any on this, I am ignoring this. Okay, now I can select any one of this. I am selecting the load combination as user defined, and concrete design criteria AC 3 on 8 14. Okay, now the reinforcement, I can select the reinforcement later. First of all, I can although I have mentioned it, reinforcement selection is prior to here the reinforcement selection step is here I have selected the checking result. Checking is after the reinforcement setting, but I can check it result first. Here the result is pile axial capacity ratio. Pile axial capacity ratio is 1. Okay, That means the pile number of pile has not passed, is not number of pile need to be required, or capacity need to be increased. Okay, then pile capacity, material pile capacity, we have capacity 219. Okay, the pile axial capacity ratio now is within the allowable limit. My allowable limit is 1. Pile group horizontal ratio is at 0.3. Okay, now load transfer column design. Okay, design structural design capacity ratio is 0.8. Okay, one way shear did not passed. Okay, punching shear already passed. Bending design. Okay, since the since the pile cap did not pass, so I will increase the pile cap thickness of pile cap. Okay, pile cap thickness I have used here 36. I can make it 42. It has reduced. Okay, 48. Ratio of the column face is 0.96. Okay, it is within the limit. Okay, pile cap thickness is 48 inch. Okay, I can see here the details, geometry, pile reaction, applied load, overturning moment, resisting moment for every types of load combination. Okay, I can also check the details calculation here. Here all the calculation is shown is as per ACI. Here the ACI equation number already shown here, 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 here. Okay, I can check the graphical part. That means here which column pile include how many load. Okay, then on a share, I can check the amount of stress or share capacity or developed share load. Here the punching area, here the on a share, here the punching area for ultimate load condition. Here the bending, here the bending moment is 1449 keep feet. In this direction the bending moment is 1066 keep feet. Here the column interaction diagram. Finally I can check on the this load, but before it I will insert the reinforcement and check the reinforcement capacity. Okay, here is the bending moment, minimum bottom reinforcement area ratio crossed. Okay, top reinforcement concrete cover is 3 inch. Okay, concrete cover, this has been here the concrete cover 4 inch plus here the 3 inch, 4 plus 3 7 inch. Okay, 7 inch. Okay, now the bending ratio, steel ratio is on 0.17. I will show hook. Okay, indentation not required. and top reinforcement. This is top reinforcement, this is bottom reinforcement. Okay, 12 nodes I can increase 14. Okay, bar. I need not increase this one. I can here minimum top reinforcement ratio. Okay, develop length ratio, top rebar reinforcement ratio. Moment. I will show the minimum reinforcement in the top because temperature shrinkage reinforcement. I will provide temperature shrinkage reinforcement at the top of the pile cap. That means I will provide 0.0018 BT equal to 0.0018 into 12 into T 48. That means 0.0018 into 12 into 48. That means 1 inch square 1.03 1.04 inch square per feet. But if I design for analyze for lateral load in load combination, then the top reinforcement required top reinforcement already here shown. That's why, since I have not checked it for lateral loads, that that's why there is no reinforcement for top reinforcement. Okay, then bottom reinforcement is bottom reinforcement 14 nodes. Okay, 16. Okay, here the minimum bottom steel area ratio is okay, for it is okay for bending design. Check. Okay, now all the issue is completed. Now we can print this space for construction, for sending this drawing to construction. Finally we can print preview, make a print preview, condensed report or details report. Okay, this is condensed report. If you want to print or details report, okay, here the details report has been generated, and finally we can send this space for construction in the site. So this is all for designing a pile cap, and thanks for mm, thanks for view this video, and that's all today. Assalamu alaikum.